So I have to confess, I actually hired this guy once. How long did you work?
How long?
Yeah, I actually fired myself first, right?
Yeah.
Yeah. So we hired this guy, and then a couple of years later, I think, then I went, and then Erik went to work for TransferWise. So he will talk about that later on.
Yeah, you spoiled everything.
Oh damn. Yeah, who would have guessed, right? So the stage is yours. Have fun, and let's go.
All right, so hello everyone. Thanks for coming. I will start with a small spoiler. I'm wearing a scarf, I have a fever, and I have a sore throat. But I believe that those small inconveniences are not going to disturb the presentation today. So let's kick it off. So the topic is probably like super controversial, right? Life after QA. And yeah, my name is Erik. And I am a tech lead and engineering manager in the online payments and card payments industry. So this field has been my domain of choice for past 5 years. And on a daily basis, I'm building engineering teams. So far, in this particular field, I have built or helped building 7 of such. And on a daily basis, we are building systems that either accept card payments worldwide or accept some alternative payment methods, not only cards. And the recent project that we had was actually building our own MasterCard debit card and all the systems from scratch, including the issuance and the payment processing parts of it. And today's talk will be based on my own story and journey, and I'm very happy to be here. And that is why, because I'm the Nordic testing dazer since 2012. I actually participated at the first event ever. And I'm extremely thrilled to see today how big this event has actually grown since then. And I think that also from my side, triggering your huge applause now, I would like to show the gratitude to all people who are making this event a reality. So let's have a round of applause. And as you might guess, since I was participating here already 7 years ago, I'm a QA person myself. Once QA, forever QA, right? And at this point, I would also love to point out that I am a ISTQB certified foundation level tester. That is extremely important information to point out right now, because never in my life before I had a reason to tell to anyone about that. And now, thanks to this event, that felt like a relevant information to share. Okay, jokes aside, I started my IT career as a hardcore software and hardware tester boy. That's how I looked back then. I think I haven't changed much. But while being a tester, I had 2 really difficult dilemmas, like professionally in life. First of all, I felt that software engineers and testers are working in silos. I felt like engineers and testers did not really form a strong union. So I often felt like sloppy engineers were just writing some sloppy code, giving it over to testers so that they can come back with bugs. And I believe that, okay, it's super controversial, right? Many people probably don't feel so. Most likely, maybe I was doing something incorrectly, but that was one of my feelings. Second feeling was that I realized quite quickly that the repetitive type of job is maybe not for me, or I'm not good enough for it. And if we have like anyone in this audience who is a manual tester, I must admit you are heroes for me, because I think that it's a really, really tough job, and it requires like very strong mental strength. that I probably didn't have, so I was always trying to find ways to escape and to automate my job. But in the industrial automation field, probably partly because of the complicated stack and the hardware component, and also, of course, because I was not good enough, that was not really an option. However, I took a chance to try becoming the automation QA professional in the web and service and server-side systems. And also for some time I was trying the performance testing role, and testing according to the spec is just like a normal automation job, but if it's possible to go beyond the limit and see where the system will be breaking, where system is running out of memory or out of database pool connections, then it actually becomes quite fun and quite entertaining activity. It's like watching the hydraulics press channel. Probably many of you know what I mean. But still, I was really not happy. I was still feeling that even the automated testing and engineering is following the pattern where quality assurance, so ensuring that the quality is made of high quality, comes always after the development process and acting as a safety net. So then I decided to become a full-time engineer that will be writing perfect code that has no bugs at all. Well, I didn't, and even if I did sometimes, I was still feeling exactly the same problem, but I was on the other side of the fence. And then I finally found my zen in engineering role, where I didn't have any safety net at all. And this forced me to rethink the whole software development and the quality assurance perception that I had up to that point. Because now the quality assurance had to be nested inside the very process of building the software, and it has to be on a particle level part of the whole organization and software development DNA. So the cost of mistakes was extremely high. It was higher than ever before, and the accompanying adrenaline rush was just immense. So I was writing a code that was responsible for moving millions of US dollars, and next minute I was already releasing it directly to production. So ladies and gentlemen, here comes the story. So this happened in a company that has the mission of removing borders in the world of finance. So if in geographical world we have countries, and for traveling we need visas and passports, so our goal is to remove those barriers and this friction in the world of international remittance and finance. So we want our customers always feel home wherever they happen to be or wherever they happen to travel. And this company is called TransferWise, and this is where I have spent the last 5 years of my life. And we don't have any QA roles at all. So this is definitely a tricky part here. So no testers, no automation testers, no QA managers, nothing. So no one particularly responsible for the quality assurance. Now at this point, this might sound scary, weird, wrong, whatever. Can it even succeed? So I would say yes. We are 8 years old startup at this point. 5 million of our customers are moving $5 billion of dollars every month, which means that every year we are moving more than 3 GDPs of Estonia. As our service radically cuts costs and time in international remittance and finance, we help our customers to save 1.3 billion every year. So keeping this money in pockets of our loved customers. And we are also still clearly a startup because depending on the market, we are still growing 50 to 100% year to year. So in some markets, we are still doubling up in size. Anyway, also according to freshest newspapers, we are actually the Europe's most valuable fintech startup, being valuated at 3.5 billion. So I would conclude that the product strategy and the mission statement and the business and the quality assurance models that we have chosen are proven to be successful. So now let's focus on the latter one. Let's talk about the quality. So definitely when we are dealing with a lot of money and with millions of customers, quality becomes a life and death question. So without QA department, actually whole organization becomes one huge QA. So let's talk about product engineering. It's definitely like a very deep and complicated topic. We will be just scratching the tip of the iceberg. But I hope that you will enjoy some of hand-picked principles that I selected for this talk that will try to explain how we are ensuring the quality assurance. We will be talking a lot about quality today, and in fact about different forms and variations and types of qualities. So before we start talking about software and systems quality, which is probably more traditional topic, I'm proposing to have a conversation about product quality, because having no bugs and perfectly functioning code doesn't mean that the product is great. Definitely having a great software is a prerequisite for a strong product. That's just the product engineering science. What are the options to measure and track the product quality? Have you ever been asked how likely are you to recommend some product or brand or feature to your friend, colleague, or your relatives? This is a very powerful question. Very, very powerful. Many of you probably have heard about the term NPS, which is Net Promoter Score. It is one of very, very commonly used metrics in product development. And analyzing the NPS, companies can understand why they are growing quickly, or maybe some others can try to understand why they are not actually hitting the growth targets and goals. So if you ask this question, no matter how directly or find some other fancy ways how to ask this question from them without them maybe really realizing that, answers between 0 to 6 are called so-called detractors. These are the people that don't like your product. For some reason they have been using it, but they don't really like it. 7 to 8 are passives. They might be loyal, but they are passive. And 9s and 10s, these are your fanboys and your fangirls. These are the people who are telling about your product to their friends, to their colleagues, to their relatives, to even random people on streets. So these people are driving the virality, and these people are bringing along your hypergrowth. And no marketing can ever be as powerful as the marketing of virality. You might be spending millions and millions of dollars on the paid marketing, but what matters the most is to nail the organic virality. This is the most important part, period. So promoters promote your growth, detractors detract your growth, and NPS percentage is the percentage of detractors detracted from the percentage of promoters. So with this simple math, we can just conclude that the NPS value can be between -100 and +100. So experience of thousands and thousands of companies is showing that if your score is above 50, then most likely you will be hitting some really good growth numbers and that your product is healthy. So the higher the NPS, the steeper the growth. Again, the product growth science. And NPS can be also very seasonal because if some company is involved in some bad publicity or some well-known scandals, their NPS will be dropping almost immediately, just like their stock price. And also for established companies, it has a tendency to decline in time, because if everyone is using Google already, then you are not really going and proposing others to start using Google, because everyone is using it anyway. But for startups that are only growing and are in the growth phase, the correlation between NPS and growth figures is proven to be very, very strong. So the NPS of TransferWise is 76 today. It is usually floating between 70 and 80, and it's a strong figure. And we have actually full-time dedicated teams, which are called the virality teams, that are working hard on a day-to-day basis to keep this number high. However, plain dry NPS number itself is a cool indicator, but by just looking at it, it is not actually like providing very much information. So what really matters is the analysis and the categorization of the NPS feedback. So now for a second, let's not talk about TransferWise, because I clearly have some unfair domain knowledge advantage. So let's talk about shoes. Products have so-called product pillars. These are the existential foundations that the product's vision is based on. And pillars for shoe could be design, comfort, price, and durability. And trust me, if you are building a shoe product and you will build shoes that last forever, are nearly free, are comfortable since day one, and have just spectacular, amazing design, you will have a huge NPS, and for years and years you will have exponential growth. Of course, the problem here is that turning such product into a financially viable model is a true miracle. No one can really do it. So the art of the product development is actually good. It's about finding the right levels for those product pillars and a good balance between them. And the technology is used to raise the level of your pillars to new heights. For example, by using the technology to reduce the production cost, helps you to reduce the price. That will increase your NPS, and the growth will follow as well. So once you have identified those major pillars that your product vision is based on, we can start analyzing what our customers are actually telling us. So we are actually especially interested in the feedback from detractors, because they don't like you and you want them to start liking you. So you need to have a mindset to measure everything that your customers are telling you. So if shoe soles are falling off, then you need to invent a metric. For example, the average duration of the sole life cycle and when it starts falling off. And you need to start measuring this average or mean, and optimize, measure, optimize, measure, optimize, measure. And you need to start attaching metrics to all topics of feedbacks that you receive from customers. And then you need to pick the most important metrics that you will focus on, and these will be your North Star KPIs. So KPIs are key performance indicators, the most important KPIs that you focus on. Usually the amount of KPIs should be low, but the amount of metrics should be as high as possible, so you understand the product performance well. So getting the NPS feedback requires some effort. You need to find ways how to ask this from customers, not be too noisy, not piss them off. However, one really good source of information is actually customer contacts. And believe me, if customer chooses the effort to call your customer support, then most likely she is a detractor. And again, categorization matters. So you apply the similar formula. So in TransferWise, we tag every single customer support call, every single email that we receive, every single comment in social media like Facebook and Instagram. So we attach data to everything that comes in, we categorize it, so we get the weights for those metrics. As a result, we get the KPI tree when on one hand we have why we are even looking at something, and then on the right side, we have how we are going to fix it and what metrics we need to change in order to improve this situation. So talking about customer support, and now we can get back to the TransferWise topic and stop talking about shoes. We in TransferWise, we treat customer support as a part of the engineering team. And this is important because we have built so-called customer support champion model where all customer support agents, or not all, but many of them actually have some sort of specialization and some sort of product ownership within the company. And they are extremely important for us because customer support is our direct link to customers. So it's direct access so that we can actually experience almost ourselves what customers are feeling about the product. And our product teams are autonomous. It means that we don't have any top-down decision making. For example, I can bring the example of my team. The smartest people in the company in the card payment industry are in the card payment team, which means that no one else from above can tell them what to do. It's more the other way around. The whole company expects that those small teams will be telling the whole company what is the smartest thing to do with cards next. And to achieve that, those teams also need to own their hiring, and this is important. And they also, of course, own this product and involve all roles into putting together the roadmap. And also, we shadow each other. And this is also very important because, for example, when engineers are deciding what to build next, one of the most valuable information can be coming from customer support, but at the same time, all of our engineers are also time to time going to the customer support floor and taking calls to answer customers and to have this direct relationship with customers and hear what's happening. And in addition to that, even our founders are doing that, and even our investors are doing that. So a couple of years ago, one of our US investors, Ben Horowitz, came for the board meeting, and he went to the customer support area and he started taking calls, because in addition to hearing from us and product managers how we are doing as a company, he obviously wanted also to hear some opinions from customers. And this is how we build the high quality products. Another type of quality is the engineering organization quality. So high quality engineering teams are building high quality software, and high quality software is needed to back the high quality products. Have you heard of the microservice architecture? So I believe that many systems today have this term. And in hyper-growth companies, technical architectural decisions are crucial. So system needs to scale. And the expansion of the features and the functionalities needs to be as frictionless and as convenient, as efficient as possible. So normally, some system contains of the application layer, let's say some Java application, and the persistence layer, let's say the database. The most likely for failover and from load balancing reasons, there are multiple instances of the application and probably a clustered database. And this single application approach is often referred as the monolithic application. And as a product grows and companies start facing first problems with that choice, because usually every release is taking down the whole system, it becomes inconvenient and slow, develop new features, so they decide to split the application in half so that they can cut their problems in half. Normally, according to definition of healthy modularization, services should not share databases. They should have their own databases. They want to be independent. And usually decomposing the database part is actually the most complicated step in the modularization projects. And then the company is growing, so they keep adding new and new services. And a rule of thumb is that every application needs to have a single responsibility. So every application is responsible for some certain feature or some certain functionality. So in TransferWise, we have 169 services as of today. It can be easily be that in 1 month from now, this number can be 180, so it's actually like growing really quickly. And this is how it looks like. And also, if we consider that each application has at least 3 nodes or 3 instances, and also all of those applications are actually running in at least 2 availability zones and in separate clusters, you can just multiply this picture by 6, and this will be roughly the size of the TransferWise application. And this is a lot of services to maintain, right? So our engineering teams actually own only some certain parts of the application, and the borders between teams are usually defined by the borders between services. And with this ownership, there comes great responsibility. So all engineers in TransferWise have personal access to release their services straight to production at any given time when they want. And usually teams inside agree when they actually release. This is a huge trust, this is a huge responsibility, but thanks for that, we have 1,500 releases every month. So 1,500 times we release new version, new improved TransferWise to our customers. And this great cadence is exactly the reason why we cannot have the quality assurance after we write the code. It needs to be inside of the process of code writing. So now the fun begins. Let's discuss how we make this luxury possible and how we are so far not failing with that. So 100% test automation is the strictest rule ever. So engineers who code some new features or functionalities are the best positioned and the most efficient ones to cover those functionalities with 100% test automation. So we require 100% unit test coverage, 100% integration test coverage, 100% controller level coverage, and we don't hesitate to write system-wide tests either. So according to my own observation, if I'm coding some feature, usually I spend maybe 30% of my time doing the coding itself, and then at least 70% of time covering everything with tests. And due to that, all developers, every single of them in TransferWise is a highly skilled test automation engineer as well, and it's actually a prerequisite to get the job. And because of that, we also promote test-driven development approach and the mindset, because it helps to ensure this coverage. And if some pull request doesn't have 100% test coverage, then it's not going to be approved, and those changes are not going to production, period. Then automated tests definitely help you in the build time, so they are decreasing the regression mistakes and decreasing the possibility of releasing some problematic changes to production. However, definitely it's not enough, because issues might happen, and especially with 170 services, there are plenty of things that can go wrong. And we require our engineers implement monitoring for the features that they build, so they need to think through how the application will be analyzing itself, what are the normal values, what are the necessary metrics, and whenever something in production looks abnormal, then the application should send push notifications to our phone, and we need to be the first ones to detect that. So this is about 25% of real-time monitoring dashboards that we have for the payment card product that we shipped about 1 year ago. So I couldn't place everything here because this stuff would be too small. So it's a requirement for every engineer to build products that test itself 24/7 and inform us automatically if something goes wrong. So this is the second layer that helps us to keep the quality. And then let's talk about test environments. So usually companies have several environments of their application, production, the holy grail, and some pre-production environments, so some replicas of the production, let's say some pre-production and some staging environment. And let's imagine that this sandcastle is our system. Every tower is a microservice. And we decide to deploy some new tower or refactor it very strongly or add a new tower. So in TransferWise we have 306 engineers and we have continuous delivery in pre-production and we have manual releases in production. So when 300 people start playing with the same sandcastle, then it becomes a mess really, really quickly. People deploy different towers that don't match or don't work with each other, and the sandcastle just becomes messy and broken. And once it's a mess, no one wants to play with it anymore. And at the same time, no one actually wants to spend time fixing it because they don't feel that they have broken it. So it becomes a serious problem. So one option for that would be to give every engineer their personal environment so that they could test whatever they want without being distracted by others. But unfortunately, this is not feasible at all. If we have 170 services, we want to have at least a couple of instances for each. For example, if you want to test some failover scenarios, and then we multiply it by 300, so you can do the math. It is just impossible financially. We will be doing a suicide. So we invented a system which gives engineers personal environments on demand. So every engineer can now get their own castle when they need. And we called it the TransferWise custom environments. So as our deployments are based on Kubernetes, we have a friendly Kubernetes bot who is helping us to do this hard job. And we can talk with this bot in Slack. Slack is our messaging platform of choice in TransferWise. And the most important commands are create and delete the environment. So for demo purposes, I created the environment called Erik Nordic Testing Days Demo. I did it from my phone. And in 4 minutes, it spinned up a small copy of TransferWise for me, which has the databases, example data, and it also comes with production-alike tooling, so I can monitor it, I can see logs, I can access database, and I can do everything that I would do for troubleshooting in the production. I hope that you were impressed by that, because I personally am super impressed by the system. As we are extremely data-driven in everything that we do, we also have some certain metrics that we use to track and evaluate the quality of our engineering teams. Again, we are thinking that we need to have really high-quality teams to build the high-quality software, to build the high-quality products. To start with, we keep a track at growth and the distribution of code across services and across our code base. So this helps our leads, our technical leads, to spot where things might be becoming dangerous. At this point, we have 3.5 million lines of code in services, and few millions also in mobile applications, in the web front end, and in libraries that we build for the internal use. So when it comes to microservices, we keep an eye on the modularization. So we want to see the ownership of teams, how it is changing in time, how many services teams have, how big are those services, and to just make sure that some small microservices are not growing into the next monolith that we will need to decouple in future, and it becomes a problem. And to assess the efficiency of engineering organization, the cross-team collaboration is a very important aspect as well. So we use something which is called we code ownership. So all teams own some services, but they can do modifications in any service that is owned by other team. But only the team that owns the service can approve those changes and move this stuff to production, which means that it becomes definitely a factor that is slowing us down, and we want to keep an eye on how much of those cross-team collaborations is required to change and improve TransferWise. So having numbers in front of us, it motivates us to clean up the code base, remove unnecessary or outdated chunks of code, so to keep this hygiene of microservices and the code base. And the simple rule is, the smaller the service, the faster the release cycle. So the more efficient we are in bringing those 1,500 updates to production. And also, one of very important metrics for engineering organization is the lead time. This is the time from some engineer starting to work on some challenges until releasing it to production where it's fully functional and available to customers. So this is, again, something that definitely is increasing the speed of delivery very significantly. So we always aim to get the average of lead time and the mean of lead time to as minimum as possible. And we have 4 key metrics that help us to understand what's going on. So to reduce the lead time, we reduce different wasteful activities, which in turn lets us to deploy more frequently. More frequent deploys helps us to improve teams, their practices and automation. And the speed to recover from different issues that might be happening in production is improved by better practices, automation and monitoring. And that, as a chain reaction, reduces the frequency of failures in prod. So this is a beautiful chain reaction, and I often like to say that our teams are turbocharged. So the output of their work, the way how they do it, is actually increasing the efficiency of the organization and increasing the power of the delivery. And this way, instead of slowing down as the company is growing, actually we start to deliver more and more and more. And with this number of microservices, I think a couple of years ago I was giving the presentation, the number was somewhere close to 50. So as the company is growing, we are actually starting to deliver only more, which is awesome. So all changes need to be approved before they go to production. So we already talked about some hard requirements like test coverage and the monitoring needs. So reviewing principles are strict, but also PRs become definitely a bottleneck when it comes to the delivery. So we also track the average time it takes for PR to be approved. So more frequent PRs are usually smaller PRs and are faster PRs. So we also track how much people are actually having discussions in those PRs, because PRs have this built-in commenting functionality. And if we see that in some teams they have too many debates or too many disputes, then it clearly should send a signal to the tech lead that probably the preparation work before engineers start to build something is not adequate and is not enough. Ideally, PRs should be quick, everything should be already agreed on a team level, and we just deliver it with high quality. And last but not least, we look at the duration of the release. So the faster we can release some service, the faster we can act when something goes wrong and we need to, for example, deploy a hotfix. So we track all that to increase the deployment and the delivery speed, but at the same time, it also helps us to be focused on the quality of what we actually ship. And now let's talk about sad things. So no matter how hard we try to not have production issues, they always slip in, and this is normal. But we never blame. Instead of that, we try to be honest with ourselves how we should be acting next time to not let those things happen. So if incident happens, involved engineers take the full responsibility and bravely explain to the whole engineering organization what actually went wrong. So we explain what was the impact, how many particular customers were impacted, where are they regionally located, what currencies are involved, and if there is a business impact, then also, for example, trying to come up with some figure how much money we lost. So we analyze what was the cause and also write down the case study and log of exactly who and how was fixing that thing in production, how much time it took, and we are also tracking this as well. It helps us to understand how agile we are when something goes wrong in production. And we write down those recommendations not only for ourselves and to proudly explain how quickly we were able to recover, but also for future generations of our engineers. We are keeping the log of postmortems until the beginning of times, and I time to time just go and skim through all those postmortems to remind myself about the different production issue battles that we used to have. And if things go terribly wrong and we have some really bad incident, then we actually take this transparency and honesty publicly to our customers, because we believe that they deserve to know what happened and how we are going to protect them against such mistakes in future. But gladly, it doesn't happen very often. And internally also, usually, if some service is broken, then it's only one of 170 services in TransferWise, which means that those problems are very local and most of customers are usually not even noticing them. And that's also one of very good aspects of the modularization. So the time was very limited today. I hope that the journey was interesting. And if you are interested to learn more about the philosophy of product and systems engineering that we have in TransferWise, feel free to visit our technical blog. It's tech.transferwise.com. We are also very transparent in how we build things and how we think about software development and quality. Thank you very much for your attention, and I hope to see you next time here again. Thank you.
So thank you, Erik. So we have a chance to ask a couple of questions before we call an end to this conference. There we go.
No hard questions, right?
Not really. So what does your system do when one of your 24/7 metrics falls down dramatically, like in the middle of the night?
Yeah, so we are using the on-call system where every team has always someone 24/7 on duty. Usually it's rotation-based, so today, this week I'm actually on duty, so I should be checking my phone all the time. Of course, this extra responsibility and readiness to react at night and be woken up at night is also compensated fairly. So we have those systems that just send us notification directly to the phone, so we can go and just check out what's happening. And also with this on-call mindset, you being on call might be not the best position to fix it. So one of your responsibilities is also then to contact someone who is the best position to help you in sorting this out and fixing the production as quickly as possible.
So you are all now on call. So who wants to have a question? You take the other one there. Okay, I'll do it.
Hey, thanks for the talk. That was really good. Have you had cases where you've hired someone and then they didn't quite adjust to your team structure and practices? Because, for quite a lot of traditional software engineering or tech industry, these practices are very, very, advanced and maybe difficult to adjust to.
Yeah, so of course, if you look at the journey, so far we had 306 engineers who work there today. With that amount of hiring, of course, sometimes you have some, let's call them false positives, when actually they turned out to be problematic hires. But I think one thing that we use to reduce the risk of problematic hires is that we have a very long and complicated hiring process. Usually we have the technical interview, at least one or two of them. We have the product thinking interview. We have the cultural fit interview. We have screening, and then we have interview with the final interview where we talk about everything. So in many, many cases, we have at least 7 interviews to learn the new joiner, and also to give them opportunity to decide if we are actually the right company for them or not. So of course, everything that we do, it's not black or white, it's not right or wrong. It's just the way we do it, and we try to find like-minded people who will enjoy such extended responsibility.
Hi. I saw, so you said you had, 178 microservices. I saw in the screenshot about where you were telling us how any of the developers could deploy to production, that you were using Kafka to keep those all in sync. But then what happens, so then you also had the screenshot of, okay, anyone can spin up an environment in Slack, right? So then if you have your own local version of the environment, but you need the data to be changing in some of those synced microservices, how do you do that locally in the one that you've just spun up?
So when the Kubernetes bot creates you the custom environment that you can play with, you have full access to it. You have access to all services, and you can deploy any versions of any services there. You can also write any data that you need to the database to simulate some test scenarios that you might have. And just by providing full access to your own playground, we incentivize engineers to do the manual testing if they need to.
We got you there now. I have a question. I mean, overall in banking and in finance sector, there tends to be a huge reluctance to let people access the live environments. So I'm just curious, how do you handle that? Or probably most people would be curious. How do you handle the risk of so many people having actually access to live?
Well, when it comes to compliance and due diligence, then there are very certain requirements which are required by financial regulators, and also to work with some partners, we need to prove to them that access is very clearly limited and segregated. But when it comes to engineers, then they actually only have access to the code base. So they don't have access to backend systems, they cannot see customers, they cannot see the production data, and if they can, then it's very strongly obfuscated. And all that for a financial service is extremely audited. So probably the audit level and the strictness is higher than for most banks in the world, just because we are a financial service with huge volume acting in very, very many markets, and the attention to those details is extremely high. And for that reason, we actually have dedicated audit teams which are spending time with auditors and making sure that we satisfy all regulators and authorities everywhere we do something.
Any other questions?
Yeah, one from here.
Hi.
I'm sorry if I missed it, but do you do staged rollouts as well, or rollbacks when the metrics go down, like automatic rollbacks or something like that?
At this point, we don't, and we try to rely on the fact that like usually like engineers can do the same like almost instantly. And if there was a chart about the release time per service, many of those services, like releasing of them takes only 1 minute, full release for the service. Probably because of that, we haven't decided to give machine the option to decide what to do with the production system. But of course, it's quite some overhead on having more engineers 24/7 on call.
It's somewhat about lowering the risk as well, right? So if you do like stage rollouts, you can like catch some problems like early on and affect like a smaller user base. Okay,
I can also like add some like details which will partly or fully answer the question. Like I also mentioned that in pre-production we have continuous deployment. So every time when something goes to master, it is already available in one single like replica of production, and there it is actually covered with the same like level of metrics. So actually, if something goes wrong in the staging, then I will get the same notification to my phone. The only difference will be that it will clearly state that this is not production, this is staging. However, it requires attention because master is clearly broken.
Okay, thank you.
Thank you for the talk. Very informative and interesting to listen to me at least. They're related to possible shortcomings of staging environment and quality side of the product. If you can talk about it, do you have any kind of testing in production as well in place?
Yes, so the principle of autonomous teams, and especially autonomous product engineering teams, is that every team can choose their own tools, their own languages, their own frameworks. Of course, there is like organic gravity towards some certain tooling, but they have like we are super liberal. We are allowing to let them do whatever they need. And for example, some teams decide to also write some product testing health checkers. For example, I can talk on behalf of my team for the payment card that we built, as we have also built the systems that can take money from cards. We have built a system that is automatically, I will be honest, we are building it right now, but we have a plan to build a system that will be doing online card payments with our very own card in production in real, like fake online shop every couple of minutes. And this way we will have also like 24/7 production test. But usually it's needed when there are a lot of third-party, some downstream operations or third-party dependencies. So card payment is definitely one of such cases because there is a card payment scheme and regional processors and like different partners that help us to power the product. So to have this realistic availability and system reliability figures, sometimes we decide to build a real production test as well.
So last question, I think.
Thank you for presentation. How long does the onboarding process takes after a new software engineer is hired? And if your onboarding process is generalized in the whole company, or it is different from team to team?
This is a very good question. We have been fine-tuning the onboarding process to the company for years now. And the current model that we have is that each department has its own onboarding. For example, engineers have a 3-day-long course, full days, and they learn about different parts of the system. Then we also have a general transfer-wise onboarding, which talks about all departments. We want our engineers, for example, to know about how we do the compliance, how we do the verification, how we do the anti-money laundering, how we do the customer support, how we do operations, how we do legal things. So we have dedicated sessions for that, and this is also taking extra 3 days. And then each team develops its own onboarding setup, which is particular to the product that they build. For example, in the payment card project and the product team, we usually have about 10 different sessions by different members of the team. So yeah, so we spend weeks to onboard the person. And also depending on the department, for example, in customer support, and great customer support that is turning detractors that are unhappy into promoters. This is like a serious art. So there we spend especially a lot of time. So as much as I know, they spend like several weeks on learning the art of customer support only.
All right. So Erik, I'm really happy to... Well, we have a bug in the system. Sorry about that. So I'm very happy to have you here, and you've come a long way. It's really cool to see. So thank you for coming. This is inside here is a little toolkit. So that will help you if you get this call in the middle of the night that your production is unfortunately down and something is not working right. Later on, it's hard to catch sleep, especially it's so white nights outside. So you can pull this mask on and catch some sleep that you all deserve.
Thank you.
So thank you again, and glad to have you back here. So we are almost at the end of the line. We have a couple of traditions still to fulfill. So as usual, we have a lottery. Prize for the lottery is also as usual, same procedure as last year. It's the ticket to the Nordic Testing Days conference in 2020. I hope I got the year right now. And yeah, Raivo, please come on stage with this box. So I have to do the magic. It's completely random, I can assure you. It's how deep is this box really? So this is, who is it? Oh, this is very interesting. It might be your name. So Sergei Kitaev from Kühne+Nagel, where are you? So, come. So you have a free ticket to next year's conference.
Thanks.
Yeah. So we will call you. We will let you know how you can basically redeem it. But it's going to be on the 3rd to 5th of June next year, very likely. So cheers. There is another lottery, and I see my colleague Rudolf is plucking away at the computer really hard. So all of you who have used the Attendify app on the phone, yeah, and gave reviews, all of those who gave at least 5 feedbacks are in the lottery. So now you have to do the math in your head. And in a completely randomized process, it turns out that Svetlana Pareva has won the free ticket to the next year's conference as well. No need to come up here. We'll find you, yeah? Or you'll find us. This is how it usually works, actually. So, a few things left. So we also have like participation stickers. So you can stick it any way you want. And if you don't find one on the chair, then Raivo here can distribute some last ones from this lovely goodie bag he has. And this conference, first of all, would not have happened without you, the participants. Thank you all. Give yourself a round of applause. Then all the speakers who are still here, please stand up. Thank you. And finally, I would like to ask at least most of the team to come here up on stage. As usual, we have a bunch of volunteers who make this thing happen, so the whole team, please come. Yeah. I can tell you that we probably have to keep these guys more busy, because I mean during the last year it's been very, very productive child-wise. I think we have had 5 babies in the whole team in 1 year. So some of the fresh mothers and fathers have already had to depart, but 5 babies? Yeah. So next year we will have to have some sort of a kindergarten type of thing here, somewhere in the corner. But thank you for coming, and see you next year.